Hey guys, my name is Luca and I'm a model engineer and I build moving steam engines. I bet you I can build a decent sized moving steam engine for under $200 and I bet you it'll take me less than 6 months. Now I've written hundreds of articles on this topic for various publications and I've found that I'm not very popular because I challenge the status quo. I don't do things the way that people say things need to be done. I find new ways of doing it. I find new alloys and I build quickly and much cheaper than some of these older techniques. If you want to find new ways to do model engineering, if you want to develop new innovative ways, then this channel is for you. So before we get into the build that I'm actually going to show all of my techniques with, here's some of my previous builds. I hope you enjoy them. So if you're looking at building your first model, here's a little piece of advice. Don't listen to anyone. Build what you want to build. If people say it's too difficult, don't worry, you'll sort it out. If you can't make something, you'll work it out. You'll find a way to do it. Don't listen to the naysayers. Anything is possible. One thing I will say about your first model, don't take on too many projects at once. I've seen guys that are building 4 locos at once. If a loco takes 5,000 hours to build, if you build it from scratch, I mean, that's a 20,000 hour projects lined up. Not anyone can do that. So just bite off a piece of cake that you can handle. But when it comes to your model, choose what you want to build. The model that I'm going to show in this series is a relatively simple model. It's a model that I enjoy building, and typically when I choose a model, I have a couple of sort of things that I look out for. One, it needs to be a once-off prototype. So in other words, the guy built one, he never built another one. 2, the model was generally way ahead of its time. It was, and this model specifically, was probably about 60 years ahead of its time. It only took 60 years before people started doing what he did. Unfortunately, the model or the prototype didn't work because it tended to break down, which brings me to one of the other reasons I chose this model. It had known issues, and I love choosing designs that had known issues because that gives me an opportunity to try and work them out, solve them, build a model that's stronger than the prototype, and it becomes more engineering intensive, more interesting. Introduction to my model. It's the Willis farmer's engine, and it looks a little bit like this. So those of you guys that have read a construction series in a model engineering magazine know that it's tradition to start any series with a little bit of background on the model or the prototype itself. And I'm going to do the same with these videos because this model is relatively interesting. There were a couple of innovative things for its time. So the best place to find information on these very old prototypes is, of course, old books. And most of the books that talk about steam traction engines mention the farmer's engine, but they all sort of get their information from an earlier source, and that is the Practical Mechanics Journal. And I managed to track that down, so all the information and all the dimensions and the drawings that I used to construct this model comes from the original source. But I want to read something out of this journal for you guys because it's actually very interesting, these old journals. And remember, 150 years ago, the language was very, very different. So this is how they describe this engine. The arrangement of this engine, to which we have given the name of the farmer's engine, is by Mr. Robert Willis of the establishment of Messrs. E. B. Wilson and Co. of the Railroad Foundry, Leeds. And we are persuaded that, as a farmer's prime mover, it will be found to possess qualifications of a good, if not first-rate order. I love the way they spoke in those days. So here's some interesting information and sizes of the actual prototype. Now this is what we're going to model. The front wheel was about 2 foot 8 inches and the rear wheel was 4 foot in diameter. Now I'm modeling at a 2-inch scale, so the rear wheel at that scale is typically about this big. And this is a nice size for an average home workshop lathe. The cylinder itself was a 6 1/4 inch in diameter with a 10-inch stroke. And again, the cylinders would typically be about this size, which is a nice size for a home workshop lathe. It didn't have the standard cylinders that went on the top of the barrel. It had two cylinders pistons that went underneath the barrel, and then that went to a common crank with a gearing, and the gearing was about 1 to 2 1/4. The driver and fireman stood at the back, which only happened another 60 years later. Typically what they did for the earlier farmers' engines is the driver would sit in the front and the fireman would sit at the back, and the two would communicate like this. Where this engine, both guys sat at the back, and there was a mechanism from the back, the back end, all the way to the front of the road locomotive or farmer's engine. It took them 60 years to get to that point again. Another interesting thing that this farmer's engine had is the boiler itself was actually seam welded. Now this welding isn't what we typically find today. In those days, seam welding was skilled labor. These guys would fold the metal over and over, and you would get like a forge welding process. That skill has been lost over time. Can you imagine pressurizing a boiler that's been seam welded like that? And that barrel was almost 6 foot long, so it was a steam-tight weld over quite a length. There was a number of other innovative things for the farmer's engine. The versatility of this machine was incredible. What they could do is they could actually put the machine in neutral, and they could run thrashers or whatever they wanted to run off of the main axle itself. They could also take the wheel off or run off the secondary axle, or they could put a belt around the main wheel itself. It was incredibly versatile. It did have a governor at the top of the engine which helped control the speed. It had a pump on the side, and the pump had a tank that sat under the firebox. Now that was interesting because it actually preheated the water before it fed it into the boiler. It didn't have an injector, and I'm probably not going to put an injector on my model. I quite like the idea of only having a pump, and to be honest, if I run out of water, I'm just going to pick up the back of the model and let it run for a while to pump it into the boiler. So there are rumors that Joy from the famous Joy valve gear who was a locomotive superintendent at that time, and Willis were actually good friends. And there's a couple of places on the Willis Farmers engine where you can actually see that. The suspension at the back is very similar to what Joy used in some of his designs, and there's a number of other steam locomotive ideas that were incorporated into this farmer's engine. All in all, this is a fantastic prototype to model, and I'm looking forward to building this. Okay, so where are we going with this series? I want to show you new methods of riveting and how to cheat with rivets, because I've never bought a rivet in my life. I actually make them. Don't buy fasteners. I make my own fasteners and I cheat there as well, so I'll show you those techniques. I'll show you calculations. I can't show you my well, I can show you my dynamic simulations, but I can't really show you how to do them. But what I will do is I'll show you my hand calculations that I do just before I do my dynamic simulations of my models. So that I'll get to at each part. I'll show you new ways of casting. I developed a new alloy that I use for a lot of my cylinders and bearings that is way cheaper than gunmetal. It's easy to cast in your backyard and you make it from scrap lying around. I'll show you ways to make patterns using 3D printers, because let's be honest, that's the way that the world is going. There's tons of stuff I want to show you guys. So what I'll do is, each video, as it reaches a threshold of views, I'll post another video and another video and another video, and we'll go like that. I hope you guys enjoy this series. It's going to be a lot of fun. But I need to get back to making the stuff that I'm going to tell you about.